In this video, we'll take a look at how to manipulate textures and plot pixels in HLSL without using any for loops to keep things more efficient. We'll also take a look at how to make our own noise or randomization functions in HLSL to randomize colors or patterns. To begin, we'll start with a brand new material and start thinking about something very simple. We're going to think about kind of how an image is formed. If we have an image like this, that's a square, and we were to break it up into pixels or rows and columns, where each row and each column defines a pixel. So something like this, where we have maybe 1, 2, 3, 4, 5 rows and 1, 2, 3, 4, 5 columns. This could be our grid of pixels. And if we want to fill certain parts of this grid in to form a picture, like if I were to fill in these grids, we kind of get 2 parts that are shaded in here and 3 parts that are shaded in here, making a face-like shape. So if I wanted to describe this in an array or rows and columns with values and output that through HLSL as an image onto my UV space or my surface, we could technically do that. And we could define this as an array of values. So let's take a look at how we can do that through code. So to define this in code, we're going to start off with an array. The array will be an integer, an array of single values. And we don't really need a float because we don't really care about the decimal places. So an integer will work fine. So we'll make an integer array called grid array, and we'll make it 5 rows and 5 columns. And then we'll define those rows and columns. So the very first thing would be maybe 0, 0. The whole first row would really just be zeros. So there we go. I got my 1, 2, 3, 4, 5. 5 rows of zeros. And then the next thing that we would do is the next row. So I'm just going to copy these and paste this 5 times. So we'll have, where you have it, 1, 2, 3, 4, 5. There we go. That's my array. 5 rows, 5 columns. Now, if we want to draw that face, I'll put this as 1, 1, 1, 1, and 1. And now we can kind of see the rows and columns that are set with a value of 1. Those would maybe be the pixels that I display as white, where 0 I would just display it as black. So that would describe or kind of be able to set values for these different rows and columns, making up an image. So as long as those values are there, I just have to find a way of outputting these values as almost pixels or filled in blocks or sections of my UV space. So to do that, we first have to make our UV space also end up being 5 rows and 5 columns. So if I have to get my UV space to have 5 rows and 5 columns to match up with my array, let's take a look at our texture coordinates node. So if I take a texture coordinate node and preview it, we get from 0 to 1. Now, what we can do is we can multiply this. And we've kind of done this before. If we multiply it by 5 times and then preview that, now it's going from 0 to 5. Now, if we take that and we do something like floor, it will round everything down to the lower value, or round everything downwards to the value that's lower. And that way we won't get decimal values. It will just end up being blocks going from 0 to 5 and 0 to 5. So if we preview this, there we go. This block is 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Technically 5 values, but it starts counting at 0. And same thing for the y values. So this is kind of what we want now, because now even though I'm seeing those rows and columns or those values displayed as color, we can tell that this is 0, 0, this is 5 and 5. So we kind of have our rows and columns displayed here with the UV space just being a solid value for each one of these blocks. So now we can achieve this exact same thing through our code. So I'll go back to Visual Studio Code here, and we're going to do the same thing. We're going to define our UV space. So I'll do a float2 because we're defining U and V or X and Y space, and we'll call it UV grid, and we'll make it floor. We'll get our UVs, and we'll multiply them by 5. So it's 5 rows and 5 columns, matching up exactly with our grid array, where it's 5 rows and 5 columns. Now, to actually use this code, we'll have to make a UV input on our custom node. I'm going to go back to Unreal very quickly. I'm going to delete all this. I'm going to create a custom node. I'll create our texture coordinate node. And again, we've done this all before, so it's nothing new. And we'll just connect that up to our custom node and make it connected up to a input called UV. So I can now use the UV within our code. So there's our custom node, and then going back to our code, we have that UV defined here, and it's multiplying those UVs by 5 and then putting it in a floor. So it ends up rounding everything down. So there's no decimal places. So now to output our grid array as image, it's actually very easy. We're just going to return our grid array, but all we're going to do is for which row and which column it's returning, we're just going to reference our UV space. So we'll return whatever row and column it is on our UV space as whatever value it's going to return from our grid array. So it'll easily just match up those data types and return whatever values we have in here as a color, as black or 0 or 1 as white for whatever part of our UV we're on, for whatever column and row in our UV space that we're on. And remember, in HLSL, our code is essentially evaluated per pixel. By default, it's a pixel shader. So it's not like we're writing code to put all the pixels together. It's evaluating all the pixels at once and running everything through this code all at once. So we end up taking our grid array, and for which row and which column we're on, we just reference our UV space, UV grid Y and UV grid X. And if we do that, code like this, and we take that, and we go back into Unreal, we put that into our custom node. So there we go. And we can already see it, but there we go. We'll connect it to emissive. There's our little face shown. And if we were to change this array, like add another 1 to one of these rows, there we go. Now we can extend those lines there. Or if we were to also do that to the very top row as well, maybe we'll give some extended eyes to this face. There we go. So very easily we can manipulate our array and output that as an image. Now let's do something a bit more complicated. I'm going to take the custom node, and what we're going to end up doing is we're going to add a additional parameter here, or an input. For our inputs, we're going to add one more thing, and we're going to add a texture. So let's call it text. And maybe we'll plug in a texture. So I'm going to take a texture sample node, and it's going to be this Unreal logo that I have. It could really be anything that you want. And I'm going to right click, convert it to a texture object, and connect it up. So now we're feeding some texture data into our custom node and the UV coordinates. And we're going to go change the code. So I'm going to jump back into Visual Studio Code, and I'm just going to erase all this, and we're going to start all over again. And we're going to create something a little bit different. We're going to take that image and we're going to output it as kind of grayscale blocks or a pixelated image based on a resolution that we define, or based on a grid size that we define. So I'm going to define that grid size, float2 for x and y. We're going to define a grid in x and y. That grid size is going to be maybe 24 by 24. We'll just start off with that. And what we're going to also do is modify our UV dimensions to match this grid size. So we'll do a float2, call it UV grid. These are modified UVs. We'll do a floor. We'll take our UV space, multiply it by our grid size, and then we're going to divide it by grid size. Now, why do we divide it by grid size? If we don't divide it by grid size, our UV space goes from 0, and then we multiply it by 24, so it ends up going from 0 to 24. And we don't want that. We want it to be clamped from 0 to 1. So by dividing it by 24, it will make the lowest value of that UV space 0, the highest value 1, and then all the rows and columns in between fractional values. So we're going to do that. And then what we're going to end up doing is we're going to map the image that we've fed into our custom node to this new UV. So to do that, we'll do a float 3 values, red, green, and blue, because the image we're plugging in might have color. And we'll call this result, and we'll sample or create a texture sampler. We'll do a texture 2D sample. Our input for a texture is called text. And then we'll do a text sampler. And then we'll use our UV grid. And then we'll do .rgb. Those referencing red, green, and blue values. I don't even think we need that RGB, but you could add it. But maybe I'll go without it. So we'll do something like that. And we can go test to see if this works. So I'll go into Unreal. I'll paste this into the custom here. It's going to give me an error because it says here that undeclared use of grid size. But if I am to look at this, this should all be good. We just don't have anything returning anything. So if I were to return 1, well, no errors. You always have to return some value. If you don't, it's going to give you a bunch of errors. So technically this all works, but we don't want to just return 1 or white. We want to return our proper values. So we're going to go back to our code. So all this seems to work. The last thing we have to do is return the resulting image now. So we're going to return float, and then I'm going to return our result. So our result is our texture here, mapped with those new UV coordinates that we've modified. And if we were to do that, take a look at what we get. See, we get an error here, so float. Well, I'm outputting float 3 here, and I'm just returning float here. So that's going to give me a little bit of an error. So I'd have to do something like result.r. So I'm just returning one channel of it. And there we go. We got our kind of pixelated image now. Now, technically a better way to do this is to properly convert that image if it did have color, even though it's black and white here. If we want to properly convert it to something that's grayscale, it's going to jump back to our code. We'd want to do something like this. Return float, and then dot, and then result, and then float 3, 0.299, 0.587, and 0.114. Now, what's up with those numbers? Why do we want to do that? What is dot doing? Dot, in this case, is really just doing scalar multiplication. It's just taking this number and these numbers and multiplying, essentially. So you could actually put it as multiply as well. It'll probably give you the same result. But dot is technically better better coding practice. Even though in this case it's just doing scalar multiplication, you could do either way. But why are we multiplying our image by different values in red, green, and blue to create our grayscale image? Why are we doing that? This is because if you were to just take a colored image and multiply it or convert it to grayscale by just multiplying it by the same value for red, green, and blue, is technically not the best way of making that image grayscale. And the reason for this is in the real world, in real life, your eyes are more sensitive to certain wavelengths or certain colors than other colors. So by setting this to take the red values and multiplying them by 0.299, green values by 0.587, and blue values by 0.114, it more accurately converts it to grayscale. So not something you really need to do. It's not going to cause a problem if it looks fine to you, but technically that'd be a better way of doing a conversion from color to grayscale. But this is what we get. And if we were to change our grid size, make it 12 by 12, we get more pixelated image. Or if we were to up that a bit by 48 by 48 rows and columns, we get a little bit more detailed of an image. So now we have our image that we're able to input and kind of pixelate it in a way. Now the way we're going to make this a bit more interesting is to add the ability to have a border around each pixel. So they won't just all be like this pixelated image, it'll actually have a little bit of a style to it, almost as if they were individual lights, separated by frames in between those lights, or separated by sections in between those lights that don't light up. So how can we do that? How can we add a border to these individual pixels? Well, we jump back to our code here. It's fairly simple at the moment, but we're going to add a couple things. We already got our grid size. The next thing that we're going to do is define the size of each grid block. So I'll do another variable called float2 grid block, and it will be 1 divided by grid size. Pretty much the same right now, but this will allow us to change it if we want each grid or each section to have multiple mini blocks inside or something different. So not a super important thing, but something we'll define for a little bit of control. And then we're also going to define a float value for the border thickness around each one of these blocks, and I'll just set it to 0.25 for now. Now everything else is good. We already got our UV grid set here. Nothing there has to change. The only thing is we have to make the border get drawn around each one of these pixels. So to do that, we're going to make another float2. I'm going to call it grid border, and it's going to use a step value. And we're going to step with 0.5 minus our border thickness, and then fractional values of our UV divided by our grid block. And then we're going to take that and we're going to multiply it. We'll take that whole step function, all of that, and we'll multiply it by another step function. And it will be fractional value UV divided by our grid block, and then 0.5 plus border thickness. And by doing that, we'll be able to get a border around our block based on this border thickness here. Now we can leave all of our output and everything almost exactly the same, but we have to apply this grid border to our resulting image. So we'll leave our result as is. That's all fine. But then after, we'll take our result and we'll multiply equal by float grid border x times grid border y. Now this whole grid border here is returning pretty much a 1 or a 0. And when we take our resulting image, if we times anything by 0, it equals 0. So the part where that border is supposed to be, it's going to be 0. It's going to be a value of 0. And if we multiply that by our result, it's just going to make those borders all values of 0, cutting away from our lit up pixels or values. So that will apply the border to our image. And then we leave everything else the same here for returning the final value. We copy all this, paste it into our custom node here. There we go. Now we have this border. We can change that border size to be thicker, so lower value. Now we just get like dots, or thinner, higher values, and then at some points too high, like above 5, you don't really see anything. But lower than that, there we go. Very thin border, thicker border, and so on. So now we're able to define a bit of a border around each one of those pixels. Now that we know how to make borders, I'm going to go back to our code and we're going to take a look at how we can make some random noise. So to do this, it's going to be fairly easy. It's not going to be truly random. It's going to be a little bit of a fake random, but we're going to create a structure so we can have a function in our custom node, and we're going to call it just pixel plot. And I'll create that structure, and inside the structure, I'm going to make a function called noise. It's going to be a float noise. We'll make it take a UV coordinate. So UV coord, you'll take as a parameter. And we'll make it return a fractional value of a sine function with a dot or a scalar multiplication of the UV coordinate by a float 2, which will just be some random values like 1, 2, 3, 4, 5, 6, 7, 8. That's it. And then at the very end, we'll take all that stuff and we'll end up multiplying it. Let's see where this bracket is. This bracket here closes here. Okay. We'll multiply it by, I don't know, 9, 1, 0, 11, 1, 2, 1, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, great. Doesn't matter what those numbers are. You could type in anything for those numbers as long as they're fairly broken up and not just like a bunch of zeros or ones or something. So that's good. That'll give us kind of like a random value, and we can now use that. So now that we have this, we'll define our pixel plot structure as just plot, and we can use this. So again, define our grid, float 2, grid size equals float 2. We just define how big we want it to be, maybe 64 by 64 this time. Then float 2, our UV grid is our floor, and then UV times grid size. Okay. And then float result. Our result is going to be our noise function, so plot noise. We'll use our UV grid as our input or as our UV space, and then we're going to check, does that return a value less than 0.5? If so, output a white pixel, otherwise output black pixels. That's it. And then return result. So that's our full code. And if we take that, throw that into our custom node, don't need our texture object right now, we're just doing this, it could be disconnected, wouldn't really matter, but I have it defined here, so it has to be inputted, but we're not actually using it. But there we go. We get our randomized or fake randomized values or noise. So that's what our noise function is able to generate, which is pretty cool. So now we can use this noise function in other ways as well to randomize colors or randomize additional patterns or other things. let's take a look at how we'll be able to do that. So the very last thing that we're going to do, combining this all together, we'll go back to our code. We'll keep our noise function that we created. And what we're going to do is load our image and use our noise function to take that image and make each pixel or grid of it that it gets converted to be a different color by using our noise function to choose that random color. So to do this, we do this all over again. Grid size, float, let's do 32 by 32. Then what we do is our UVs, so our modified UV grid, floor, UV times grid size, and we're going to divide it by grid size so it stays within a range of 0 to 1, because we're going to be mapping our image to it. And then float 2, we'll do grid block. This is just again for control, and I'll kind of demonstrate this after. That'll be each individual grid inside of these UV space row and columns. And then we're going to define our border thickness, 0.25, like we did before. And then we have to do our border calculation, so I'll just call it block border or whatever. And again, step 0.5 minus border thickness, and then fractional UV divided by grid block, and multiply that pretty much by the same thing, but just flipped. So step fractional UV divided by grid block, and 0.5, but plus border thickness. There we go. Got our border. Now all we do is create the result. So float 3 result equals texture 2D sampler text sampler UV grid, and that's it. And then apply that border. So result multiply equals float block border X block border Y, and that's it. Whoops, there we go. Now that applies the border, but one last thing we have to do, we have to make each of the little blocks be a different or randomized color. So we'll do an if, we'll use the if, and we'll do dot result, and we'll do float 3, and technically we'd want this to be those same values that we had before, so they're properly converting from color to grayscale, but again, it doesn't really actually matter. So you could just put it as 1, 1, 1. It'd work totally fine for this purpose, but just to be proper, I'm going to set it to the proper red, green, and blue values for the conversion. And then we'll check if any of those are greater than 0, because if they're 0, then there's no point of choosing a color for it. It's just going to stay black. We just want it to be not filled in with any color. So only if it has a value greater than 0 are we going to randomize the color for it. So if it is greater than 0, then what we're going to do is make the result equal float 3, and we'll use our plot noise, our noise function. We'll take our UV grid, we'll plus a fractional value of just some random numbers. So 1.23, and then the next one I'm going to do is for red, green, and blue. So this is red. And then we're going to do green, and then blue. There we go. And I won't leave them all the same. We'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. Good enough. And then we finally output the full result. So return result, and that's it. And if we take all that code, go back into Unreal, paste it into our custom node, what do we get? Assuming there's no errors. Of course there's errors. let's see what we got here. So grid size, very easy errors to fix. I forgot float 2 here because it's a float 2. And then again, looking at this, I think for the rest of it, we are good. So I'll take all this, copy it again, paste it back into Unreal. What errors do we have now? Okay, so now I have a couple more errors. We just go back into our code, telling me an error here. And if I am to look at this, we got result times equal. Oh, I can't do a float. That has to be a float too. Again, just a very, actually no, this is correct, except this should be border x multiplied by border y. There we go. Border x multiplied by border y. There we go. Okay, so now we're good. Paste that back. What error do we got now? Texture sampler. So we got our texture, our UVs, called text. So it's not texture 2D sampler. It should just be texture 2D sample. And third time's a charm. Let's run this. There we go. So now we got all of our pixels showing as randomized colors. So that's pretty cool. Now, if we want those colors to be blinking, like we want to make an animated control panel or something procedurally through HLSL code, we could totally do that. We could go in here, add one more input variable, make that input variable something like time, connect it to a time node, go back to our code just very quickly, and instead make it fractional time plus, or time divide by 1.23, time divide by 4.56, time divide by 7.89 for red, green, and blue. And if we do that and bring that back into here, now it's going to randomize those colors constantly as time passes. So we get all these little blinking lights or blinking sections of these individual blocks. And if we want those blocks to be more detailed, like bigger sections of blocks, again, we have that grid block equals 1 divided by grid size. We can make it 0.5 divided by grid size. And now we get these smaller blocks that all flash in the same color. So we can kind of do that as well and make them even smaller and get different effects, or make them bigger and get different patterns and effects. So these are things that you can start to play around with, but now we know how to add a noise function, we know how to manipulate images, we know how to output arrays with data without using for loops and just outputting them based on the UV space. So a lot of things that we have here that can allow us to make a lot of image manipulation and interesting patterns very easily. If you enjoyed this video, if you learned something new, don't forget to like and subscribe and press the bell notification to be notified of future videos. And if you check out the description down below, there's a link to the Patreon. And if you are part of the Patreon, you will also get access to the PDF for this video, which goes over all the steps we went over in a little bit more detail. So don't forget to check that out. And let me know in the comments down below what you were able to create with these approaches and what kinds of videos you'd also like to see next.